Alright, so first we need to put this in standard form. And that means, X, Y, and Z. And if there's a variable missing, you put a 0 in it, for example. And the first one, you can see that the Y is actually missing. So I'm going to put a 0 where the Y is. So now I have X equals 1, Y 0, and Z equals 1, and minus 2. The next one, the Z is missing, so I'm going to put a minus 3, 2, and 0. Z is missing. And third one, everything is in there, so 1, minus 1, minus 1, minus 9. Alright, so when we have a 1 here and a 3 here, so I can just multiply this one by 3 and get rid of or transform the second row. So I'm going to put my rule here. So my rule is going to say R1 is going to multiply by 3, and then I'm going to add R2, and then R2 is going to change. So I have 3, 0, 3, negative 6, and we have minus 3, 2, 0, and 17. So this one turns into a 0. This one is 2, and 3, and 11. Alright, so now I have new matrix. We have a 1, 0, a 1, and a negative 2. And then we have a 0 here, 2, oh, no. This is the one that replaces it. So 0, 3, and an 11. And the third one, for now, remains the same. Okay, so now you can see that we can get rid of this one. So we multiply this row by negative 1. So the rule says minus 1 R1, then plus R3, and now we replace R3 because we're trying to get rid of the first number here. It's like a ladder. Our goal is to have a 0 here and a 0 here, a 0 here. It's like a ladder. So we can call it upper triangle form. Okay, so let's do R1 to negative 1. So we have minus 1, 0, minus 1, 2. And then we're going to add row 3. So we got 1, minus 1, minus 1, minus 9. So we can add this, and so we got a 0. We have a minus 1, a minus 2, and a minus 7. So now I can just erase row 3 because that's the one we are replacing for now. We're not done yet, but now we have a 0, a minus 1, a minus 2, and a minus 7. Alright, so we're making progress, but we actually want a 0 here too. And one thing we can do is we can do another rule that says R2, R3. Just change positions for R1, going for R2 and R3, because we want the 1 at the top. So once you change positions, now you have a new matrix. I'm going to do this one in green. A new matrix. We have 1, 0, 1, and a negative 2. And then we're going to swap places. Have a 0, a minus 1, a minus 2, and a minus 7. And the second one is now the third. And now we can get rid of this 2 by multiplying this row by 2. So let's write our rule as required. So the rule says R2 multiply by 2 and then add R3. So R2 multiplied by 2 should be 0 minus 2 minus 4 minus 14. And then 0, we're going to add row 3. So now we have a 0 here, a 0 here, a minus 1 here, and a minus 3 right here. So now our new matrix says that the first one stays the same, and then the second one stays the same, but the third one is now 0, 0, minus 1, minus 3. So now it looks like we have the system in upper triangular, and now let's remember which variables we used. We used x, y, and z. So if we translate back to variables, now we have x plus no y, but we have one z. X plus z equals -2. For the second one, we have no x, but we have y minus y minus 2z equals -7. The third one, we don't have z, so minus z equals -3. And we can quickly see that z is equal to 3. And then using backward substitution, we have minus y minus 2 times 3 equals -7. So minus y minus 6 equals -7. So minus y equals -1, and y equals to 1. So we found y and we found z. All we gotta do is find x. So x plus 3 equals -2. So x must be equal to -5. So we found x, y, and z. So our answer is -5, 1, and 3. And hopefully that's the right answer.